All right, so today we're going to talk about, now that we've kind of talked about how to solve equations, is how do we actually start with a word problem and go through and write our own equation and then follow through and solve it. So the first thing we're going to do is we're going to kind of look at some keywords and being able to pull out those keywords from your word problems and understand what operation they actually mean. So keep in mind, these are not the only words you could see in a word problem, but these are some of the common ones they keep reoccurring. So when you guys see words like more than, increased by, sometimes they'll use the words sum or gain. They can use words altogether. Total. And all. And combined. Again, not all the words that could mean to add, okay, but definitely some of them. So subtraction is going to be things like less than, decreased by, difference, loss, or fewer. And you'll see a lot of these are opposites of each other. So multiplication could be times, could be each, so that's a pretty popular one. Also per, product, or sometimes they'll say twice the amount, so that's a particular one. That means times 2. Okay. And then your division is going to be things like half. So half just means we're dividing by 2, or if they're splitting something. Sometimes they'll use the word quotient, and that's just another word for the answer to a division problem. And then shared equally. And then is typically means equals. Sometimes you'll see the word same as well, so if they're both the same. Okay, so let's go through and talk about how do you actually set up an equation and then go through and solve it. So the first thing we're going to do is we're going to define our variable. So we got to figure out what on earth are we actually looking for. Once we define our variable, we're going to write the equation. Okay, based on what they tell me in the question. We're then going to solve the equation, and then we're going to interpret our answer. Okay, and this is the part that's important, is we want to make sure that we're actually answering what the question is asking. And we'll see on example 3 how sometimes that can be a little bit different. Okay, so step 1, define your variable. So we're going to read the question and we're going to figure out what on earth is my actual variable standing for. So number 1 says, on a beach trip, Lucy rents a bike from Wheels by the Waves, where they rent bikes for $12 plus $3 per hour. If Lucy spends 30 hours, how many hours did she rent her bike? So notice they're asking me how many hours. So my variable, and I'm going to go ahead and use h. You can use x, but in this case my h is going to stand for hours. So when we actually get h, that's going to be the number of hours. So then we're going to go back and we're going to pick out some key things. So the first thing is this $12 plus $3 per hour. Okay, so essentially what's going to happen is she paid $12 just for walking into the bike shop, right? It costs $12 plus $3 per hour. So we don't know how many hours, but it's going to be 3 times however many hours she rented it for, and that's all going to equal to 30 because she spent $30. And then from here, we just solve this like a 2-step equation. So we're going to get rid of the constant by subtracting 12. And I'm left with 3h is equal to 18. And then I divide by 3 to cancel out the multiplication because it's the inverse, and I get h is equal to 3. And we want to make sure that we don't just say 3 because, guys, in this case it means something. So it is 3 hours, right? And when we say interpret the solution, that means that she rented the bike for 3 hours, okay, if it cost her $30. Okay, let's go another one. So it says Paul is scuba diving and is 3.5 feet below sea level. He is descending at a rate of 0.5 feet per minute. If Paul is now at 12 feet below sea level, how many minutes has he been diving? So first things first is they're asking me for how many minutes. So in this case, I'm just going to use m for minutes, but that is my variable. I am looking for the number of minutes. Then I'm going to go ahead and I'm going to write my equation. So important information, 3.5 feet below sea level. If you guys recall when you did integers in 7th grade, below sea level is minimum, or is I'm sorry, it's negative. Okay, so below sea level is negative, so this is actually a negative 3.5. Okay, so he is starting at a negative 3.5. Okay, he is descending. Descending means he's going down at a rate of 0.5 feet per minute. So he is going down 0.5 feet per minute. Okay, notice that 0.5 is being multiplied with m. And he is now at 12 feet, again below sea level, so we are at a negative 12 feet. Okay, so just to give you a visual, essentially what's happening, if they're at sea level, okay, he starts out here. Okay, he's going down at a rate of negative, so he's going down at 0.5 feet, and then now he's at negative 12, so we want to know how long did it take him to get there. Okay, so now I'm just going to go through and solve this. If it's a negative 3.5, I'm going to go ahead and add 3.5 to both sides. This is going to leave me, don't forget that negative 0.5. Okay, I'm going to technically, remember, subtract these because they're different signs and take the sign of large absolute, so at negative 8.5. And then the inverse of multiplying is dividing, so I'm going to divide by negative 0.5. Okay, and m is equal to 17 minutes. So again, interpreting our solution, it's going to take him 17 minutes, okay, to get to 12 feet below sea level. Alright, so let's look at this one. So again, first things first is we're going to define that variable. So we're going to go ahead and read through the question. So Hudson and Knox are in a race. Hudson is running at a speed of 8.8 feet per second. Knox got a 30-foot head start and is running at a speed of 6.3 feet per second. How many seconds? So this is kind of our key right there, is that my variable, again, I'm going to call S, is going to be seconds. Okay, and more particularly, how many seconds till I have ran the same number of feet. So what I essentially want is I want Hudson to be at an equal distance as Knox. Oops. Okay, so let's look at these two separate. So we have Hudson, okay, who's just running at a speed of 8.8 feet per second. And remember, my variable is S, so Hudson is just 8.8 feet per second. Okay, now Knox, he got a 30-foot head start, and he's running at a speed of 6.3 feet per second. So this 30-foot head start is him starting. So whatever he's running, we're going to go ahead, right, and add 30 to it, because think of it like a times 0. He's already 30 feet ahead, and now he's running 6.3 feet per second. Okay, so now we have variables on both sides. So remember, when we solve variables on both sides, we're going to go ahead and get the variables together. So I'm going to move the 6.3 to the other side by subtracting, since it is positive. Let's going to get me 2.5 s is equal to 30. And then to isolate my s, I just need to divide by 2.5. And that's going to be 12 seconds. Okay, so when I interpret my answer, that means at 12 seconds. Okay, Hudson and Knox, okay, ran the same distance. So they have essentially caught up to each other. All right, one more. So defining our variables. So if you guys read through this, Graham is hiking at an altitude of 14,040 feet and is descending 50 feet each minute. Max is hiking at an altitude of 12,500 feet and is ascending 20 feet each minute. How many minutes? So again, my variable I'm just going to call m is going to be minutes. Okay, my equation is, remember, we want them to be at the same altitude, right? So we want Graham to be at the same altitude as Max. So when I look at Graham, he is starting at 14,040. He is descending. Remember, descending means going down 50 feet each minute. Okay, and then I have Max, who is starting at 12,500, and he is ascending, so that means he's going up 20 feet each minute. Okay, and so again, as I'm going through this, so I'm going to go ahead and just get my variables together. So I'm going to add 50m to both sides. Remember, you could technically move the 20, right? We will end up with the same answer. So that leaves me with 14,040 is equal to 12,500 plus 70m. Okay, I'm going to go ahead and subtract 12,500 from both sides because I want to move my constants to the other side. That leaves me with 1,540 is equal to 70m. And then the inverse of multiplying is dividing, so I'm going to divide both sides by 70, and that's going to give me m is equal to 22 minutes. Okay, and it's important to realize that right now all we know is at 22 minutes they're going to be at the same altitude. Now the next question is asking at what altitude, and the answer to that is not 22. 22 is the time. Okay, but remember, we have their separate equations. So guys, if you plug this in, if you take Graham, okay, and you take his starting point, 14,040, minus, because he's descending, 50 meters per, or 50 feet per minute, and we know that they've been going for 22 minutes, and we subtract that out, okay, so that means he's going to end up at 12,940. Okay, so that's the actual altitude. I get the altitude because I plugged in the time that I know they've been going. And notice what happens if I take Max's, right, and I take his starting point of 12,500, right, and he's ascending 20 feet per the 22 minutes. So if I plug that in, okay, notice I get 12,942, right? And that makes sense because we just said that at this point they're going to have the same altitude. So they should get the same altitude on both sides. Okay, the last thing that I want to talk to you guys is sometimes you're given not necessarily a real world problem, but just an equation in verbal form. So we just need to know how to break that apart. So you have two more. Okay, so remember, more means to add. So I'm just going to kind of translate it as I see it. So 2 more means I'm adding 2, okay? than a certain number. So when they use the word certain number, that is your variable. So I'm going to call that x. So they're saying if you take x, a certain number, and you add 2 to it, is your equal sign, so equals 15 less. So we're going to take away 15. Then the product means to multiply, of 3, and again that number means your x. So, okay, and then we just solve it from there. So we're going to subtract x from both sides. You get 2 is equal to 2x minus 15. You add 15 to both sides. You get 17 is equal to 2x. You divide by 2, and x is equal to 8.5. And that's it. Make sure you guys have all of this written down.